Ciao friends, welcome to another video from SQL BI. In this video, we're going to be talking about custom visuals in Power BI reports, what they are, when you would use them, and 6 different approaches to make them yourself. We're going to zoom in on one of these approaches and talk about how you can define a custom visual inside of a single DAX measure to create a dynamic SVG image. We'll go into the details about what that is and how to do it yourself, but also the considerations and caveats of this approach. Before we do all that, let's first try to understand the context for when and why you'd actually use a custom visual in Power BI and why this is so interesting and powerful. Let's try to understand an example of a business process or problem that we're addressing in a report where a custom visual could actually be helpful for us. It's tablet time. In this scenario, an organization wants to improve customer satisfaction by delivering more orders on time to their customers. This process, which they call on-time delivery, is very important, so they need a lot of reports in order to support it. It basically goes like this, where the customer places an order on the order date, and they want the products delivered before a target date, which is the request goods receipt date, the date when they request those goods to be delivered. So this target date, which we'll mark with a different color, this is when things should be delivered on or before this date. If we deliver our order before this date, then it is considered on time. So this would be considered an on-time delivery. And this is indicated by another date field, which is the confirm goods receipt date here. However, if we deliver after the request goods receipt date, then this is going to be considered a late order. And obviously, customers aren't happy and it's going to lower the customer satisfaction. So the objective is to have more on-time orders. In order to support this process, the business wants to have reports that provide different kinds of information, including these date fields. Originally, the report provided a lot of this information all at once in a table, but this wasn't the most effective solution. Let's take a look at that report in Power BI. This is the original table taken from the on-time delivery report. It's only some of the fields, just to simplify it, but we can already see that it allows someone to get details on demand about specific order lines, including when that order was placed, when the customer wanted it delivered, when it was actually delivered, and how many days it was delivered either late, early, or on time. Now, even with these 7 fields, and again, there's a lot more fields that were in the original table, this is already very overwhelming. This is particularly true when we consider that these last 5 fields are basically just saying the same thing in different ways. The focus here is just on understanding how late or how early this order is and whether it's on time or not. It would be much more interesting and effective if we could show this in a visual way, much like how we showed it with the timeline when we first explored the process. Now, we could mock this up with a number of tools, just illustrating it and depict how this could look. For example, we could have the order date and then a line between that and the request goods receipt date, focusing on the relative distance between that target date and when the order was actually delivered. If it's delivered on time, then we could mark it blue, and if it's delivered late, then we could mark it red. This could provide a lot of information in a very compact space. However, if we wanted to do something like this, we wouldn't be able to just flip a toggle or use a different visual. We would have to use custom visuals in Power BI. Custom visuals are what you use when you need additional formatting options or a different chart type that's not available out of the box. And there's 6 different ways that you can create custom visuals in Power BI. So when we want to create a custom visual like this, we can choose between one of these 6 different approaches, which you can see in this diagram. To give a brief explanation of each of them, the first one is MacGyvering the core visuals. This basically means using the out-of-the-box Power BI core visuals and then formatting them in special ways to be able to achieve an atypical result. That's a bit vague, so we'll look at an example. When you have a bar chart, for instance, and you want to create a bullet chart, which basically means that you want to compare, for instance, actuals, like you see here, to a target. Now, how we do this is actually by using the error bars, where we add the target to both the upper and the lower bound, resulting in a mark that we can then compare to the bar. This is an example of MacGyvering the bar chart visual because we're using error bars in a way that they're not originally intended to achieve a specific visual look and feel. Now, for this case, this is a very good example of when this is helpful, but for our timeline visual, this option would just not work because there are no formatting options available in the table that we can exploit to create that timeline. Now, we could also use custom visuals that are available from AppSource. What this basically means is that we could click this ellipses, go get more visuals, if this option is available in your tenant, and we could browse for visuals created by other people, and then add those to our report. And they would function just like any of the other out-of-the-box visuals from Power BI. The only difference is that these are created and configured by other people or third parties. Some of them are free, but some of them also require paid licenses. Now, for our timeline, none of them really correspond to the specific requirements that we're trying to fulfill. So both the MacGyvering and AppSource are not going to work for us. I'll skip over the SVG custom visuals for now, since that's what this article is about. And we're next going to look at Deneb, which is another type of custom visualization that you actually get from AppSource, but it works very differently from everything else. Deneb is kind of more like a playground or a framework where you really create your own visuals and you can use them again as templates. Now, this is easier to show rather than tell, so I'll show another example. Let's say we wanted to create a bullet chart like this one, but we wanted much more specific formatting. For instance, we might want to include dots that indicate if we're on or off target in certain cases, labels, as well as specific positions of these labels, like above the target line. Deneb gives us this level of extreme flexibility and control because we're really defining the visual ourselves. When you open Deneb, the visual, so this is really the custom visual, it provides you this advanced editor where you create a specification using Vega or Vega Lite. Basically, it's a JSON-like syntax to define the visual, how it looks, how it works, how it feels, using the fields that you add to the visual. So for instance, here we've added some fields like category, sales amount, and sales amount previous year. And these create a tabular data set, so a single table data set that you can then reference in this specification to create your visual. Now, as you can tell from this explanation, this is a step up in complexity compared to the previous two approaches, but you get extreme levels of control over where everything is positioned in the visual and how that visual works. So Deneb can be really useful when we want to customize a visual to this extent, when we need that flexibility, when we really need to create our own visual. But in this case, we want to have our timeline inside of the table visual. So Deneb is not going to be useful for us. Otherwise, we'd have to create the whole table. Now, we could also use code. We could use Python, we could use R, or we could use JavaScript with the Power BI visual APIs. Python and R are both possible as a part of the standard visuals in Power BI, but we still have to create the visual ourselves in the Python code or R code. Now, this might be a good choice if you already know Python, if you already know R, or you want to leverage their specific advantages, like you have a specific use case for a more scientific or statistical visualization. But in our case, this would really be over-engineering the solution. And again, it's not something that we could insert in the table. We'd have to create the table from scratch. And JavaScript, I just don't know JavaScript. But this is also quite a complicated way to go. So to summarize, these are kind of like the low-code options where you're just using a user interface. With SVG, as you'll see, in a moment, and also Deneb, you're writing something that resembles code, but it's more a visual specification. And with Python, R, and JavaScript, that's when you're really writing code to define the visual. So the option that we're going to opt for, as of course you can tell by the title of the video and everything else that we've been saying, is we're going to create our visual by specifying the SVG in a DAX measure. To explain this a little bit further, let's first understand what an SVG is and how you actually create one. What is a SVG specification? Now, to explain this, we can use, if we refer to, for instance, here. So this is an example of a SVG image. So this is the SQL BI logo. And this is just like any image, it's rendering on our browser. We could save this, for example, to our downloads, and we can open it. But what's different about an SVG, like I said earlier, is there's a specification, meaning that we could open it in a text editor. So an SVG is actually code. It uses this XML-like syntax where it defines each part of the actual image. So this is that SVG image, but you can see that it's defining all the different parts of it using this specification. Now, if we were to take this specification, we could actually have this render in Power BI. And we can do that if we go over here. We're going to create a new measure, and we'll call it SQL BI logo. And we'll just make it a string. So we're just putting the SVG specification in here as a string. You can see there's a whole bunch of errors. But now what we're going to do is we're going to make sure that this is a valid string. So we have to escape all these double quotes. So I'll just go Control Z here, or Control D, to highlight all of these double quotes, escape them. I made a mistake here because these shouldn't be double quoted. So now we have a valid string, the errors go away, and the reason for that is because we've escaped the original double quotes and we've encompassed them in the double quotes here, so we just have a string. So this is just our SVG specification. We've just copied it into a measure and we've escaped all these double quotes so that we don't have any issues and Power BI can understand that this is a string. Now, if we then add this measure to a table visual, for example, so it's now as a table visual. For some reason, I can't select it. There we go. It's just showing us the string. It's just showing us the text. So how do we get this to show up as an image? Well, we can do that actually using this property called data category. So if we set this property to image URL, then Power BI will understand that it should interpret whatever is in this measure or column as an image URL. So this means that it could actually render. But we see that it's not rendering in this case. It's showing a broken reference. And the reason is because it needs some additional information to understand that this is an SVG. So I'm going to copy that from here. It needs this prefix. So this starter part of the code here, we need to tell it that it's an SVG image and how it should interpret it. Basically, this is a required thing that we have to add only in Power BI, not in the standard specification, so that it understands that this is an SVG image and it should render it appropriately. Now, obviously you can see that this is an image. We can render it in Power BI, but what's really interesting is that, of course, this is all code. So these are all vectors, and we could manipulate these vectors, either in a hard-coded way by deleting them, for example, and that will affect part of the visual. So we could actually replace some of these numbers with, for example, DAX measures and turn this into basically a data-driven visual, which is all what a chart is. So just a data-driven image that changes in position and size and shape and color, depending on the data that sets the properties. Now, you might be looking at this and thinking that this is quite complicated, and you're right. It is complicated. So this is something that's really important to keep in mind if you're opting for this approach. This can be interesting and you can get really nice results, as we will see. However, you're introducing things into, in this case, your semantic model that don't necessarily belong there. This SVG specification is not something that the vast majority of people are going to understand. It's hard to read, it's hard to look at, and it's hard to manage. However, there is clear value in being able to use an SVG in this way. So how can we make this easier? One way that we can do that is by using Figma or similar design tools. Now, again, it's better to just show rather than tell. So Figma is interesting because it allows us to work with SVGs. But it doesn't just understand SVG images, but also the code behind them in a way that we can copy it, we can use it in other programs, and so on. So if I copy the SVG specification, I can actually paste that in Figma, and it understands that it's an image. Then in Figma, I can actually see the different vectors that are available here. I can change their properties, like the fill, I can change their size, I can do all these kind of changes, and then in Figma, I can then copy the SVG back to be able to get the new specification. For example, if I change some of the colors, and then I copy it as an SVG, and I get this same specification then with the changes that I made. Now, this is very interesting for us because basically what it means is that we can design our SVG charts in Figma. We can copy the specification, use it in Power BI, and we don't have to worry about dealing with the SVG specification. The only thing we have to do is to make sure that it's a valid string, that it has that prefix, that it uses the image category, data category for image URL, and we need to replace the appropriate parts of the specification to make it dynamic. What we're going to do now is we're actually going to design our visual based on our mockup in Figma. And then we're going to copy this SVG specification to Power BI and use it in order to make our custom visual. This is going to make things a lot easier because then we don't have to create this SVG specification ourselves. We can just manage it in the Figma user interface. Now, we already have our mockup here. We have the order date. This is the target or the request goods receipt date. And then this is the actual confirmed goods receipt date with the variance between them. So we just need to create these different parts and then copy these into Power BI. So let's go ahead and do that. We'll create some circles, maybe make this a bit smaller and make the fill white, the stroke gray, like in the visual. Make it size 3 stroke. We'll create 2 more circles, one of which will be a bit darker, and one of which will be blue, like in our mockup. And then we need to create some lines. So we'll create one line, which will be the timeline between our origin and target. This will be the same gray color. And then we'll create a second line, which will be the variance between our actuals and the target here. We'll make these a little bit bigger. We'll also make them a size 3. Maybe make this one even a size 5. And then, whoops, we'll just put everything along the same vertical axis and bring the circles to the front. Okay. So that is essentially our visual. So we can just copy now from Figma, copy as SVG, and we will get our SVG specification and put it in Power BI. So we'll create a new measure called timeline SVG copied from Figma, and then we'll paste it in. So we have all these double quotes which are causing these errors, so we will just escape all these double quotes and then wrap the whole thing in double quotes so that it's a string. We have to add our prefix here, so this part, which is necessary for Power BI to understand that it's an SVG. We also have to set the data category to image URL. So image URL. All right. There's some things that we can also remove, like the view box, the fill. We're not going to use those, but we'll leave the width and height for now. So let's just make sure that this renders. We will go ahead and we're going to add it to our table. And if this pop-up would go away. So we now see that we have our visual appearing pretty much exactly as we designed it. It is a static image that just repeats for each of the rows, but it appears exactly like how we have it in our mockup. The contrast is definitely not very good, so we should improve that, but it is as we designed it in Figma. So our next step is that we want to take this static image, which we've created in Figma based on our mockups, and then just made it so that it can render in Power BI. And we want to make the different properties of this image, like the position of the shapes, their size, their color, all dynamic based on the values in our data model. That data-driven image is basically all of what a visual is. Having these different positions move depending on the data in our model will be exactly what we need, and we want to make sure that this is evaluated correctly depending on the context in which it's going to be evaluated in the table visual. So the first thing that we should do is we should take this SVG specification and we should break it up into variables. If we do that, it's going to be easier for us to read, but also easier for us to manage. For example, we could create a variable here called prefix, which contains the prefix. We could call this our vectors, and then we could call this our suffix. And we could put all of these together into a last variable called SVG. Which just keeps things a bit more organized, and it's going to make it easier to read and maintain. So as you'll see in a moment, we do this much more, even breaking each of these vectors out into their own variable. And then we're going to actually be replacing the values here in the middle with other variables that we define. For example, the position of certain lines, which we could insert here, for instance. And this will render appropriately, but when we replace this static value with a dynamic value, for example, a measure like the days between the order date and the confirm goods receipt date, then it's going to change depending on the values of the measure evaluated in the appropriate context. So let's go ahead and do that. Let's move away from the static version. We'll remove it from the table. Let's also clear up some room here. Let's remove the status field. And we are going to work with this intermediate version that I've already created in the interest of time, which has done a number of things that we'll explain. So we can see that this looks complicated, and I'm not going to tell you it's not. It is complicated. This is one of the important considerations and caveats of this approach, is that when you're getting more flexibility, you're dealing with more complexity. So it's important that you do things like use variables and use comments, make sure that it's easy to read, to understand, and to manage, not only for other people, but also for you in the future. That way you can avoid issues, bugs, and other problems when you actually go to implement this. So if we look at what we've done here, we've indeed broken out each of our vectors into their own variables. For example, this timeline variable, which is a line from the 5th pixel to the axis max, which is in the middle of the visual, as you'll see in a moment. And it is also just 1 pixel wide. So it's just y1 is the height divided by 2, which is the middle of the visual. And the y2 is also the same, which just means that this is just 1 pixel, because it's the same value. Now, axis max, all this is it's just determining the middle of the visual. It's the width divided by 2, which is the position of the target along the x-axis. So we also saw this in our mockup. If we go back to Figma, the target is always in the middle of the visual. The origin is always in the beginning, because this is a relative timeline. So the distance between our actual date is relative to our actual target. So when we add this intermediate, and we just, again, wait for that pop-up to go away, we'll shift this a little bit. So we can see that we get our visual pretty much as we expect. It's blue when it should be blue, it's red when it should be red, and the position of our actual dot is responding to the appropriate distance between it and the target date. Now we also see that the dot is missing here, and the reason for this is because it's so late that it actually goes beyond the axis. This is a condition that we might need to handle before we finish this visual, but there's also some other bugs that we'll go over in a moment. First, we'll try to finish explaining how we make this dynamic. Now, we explained one of these vectors to, again, the timeline. So this is the gray line, which we see here. And it just basically is saying that it's in the middle of the visual, and it's from 5, which is the origin, to the axis max, which is our target position. We have a number of other vectors, including the origin, which just corresponds to our order date. This occurs at the origin along the x-axis. The y is just happening in the middle, and it just also has some other static properties like the radius, it's white fill, and it has a gray stroke. The variance is more complex because this is a line that also has some conditional formatting. Now, this line is between the target and the actuals, and it's also just 1 pixel wide, but it also has some conditional formatting. The conditional formatting we define up here, where essentially the off-target fill is red, the on-target fill is blue. So if actuals are greater than the target, in this case, basically that we've delivered after when the customer requested, then we're going to use the off-target fill, otherwise we'll use the on-target fill. And this variable is actually what is then replacing here. So we're using this in that stroke. We could instead replace it with our stroke conditional formatting here, which is the same thing, just a dark red and dark blue. And that's actually a mistake I made when writing this custom visual. So we can see that the dark color then corresponds, but it's barely noticeable, to be honest. So this is basically all we're doing. And this is also why we've separated out these vectors into their own variables, because then we can go in and for each of these properties, choose whether we want to make them dynamic or not, and then we insert a variable that corresponds to whatever the dynamic value is. Sometimes that's just a static value that we can more easily control. For example, if we want to set the height to 10, then it will change everything else in the visual to make it dynamic so it doesn't break. So it just gives us more easier control of the visual, makes it easier to maintain again. And sometimes it's an actual result of a measure. So we have here our actuals, which are the days that we take to deliver versus the days that are between the order date and the requested delivery. And we might even manage these, for example, to determine the actual position, where we take the actual, we divide it by the target, and then we multiply it by the axis maximum to get its relative position. So we can figure out where along this axis we should actually put that dot. Because if we just took the actual raw values, of course, this is going to be much larger than the width of our SVG, and it won't appear in the appropriate spot, which is why we need to make it relative to the width, and why it's also important to make this on its own a variable. Now, there's different ways to approach this, but first, let's look at some of the challenges here, which, as I said, it's more likely when you're creating your own visual that you have bugs. And I already pointed out one of them, but we're going to look at it again. So we have cases here where there is no confirmed goods receipt date. This basically means that these are undelivered. However, even though it's undelivered, we can still see that there are blue dots and lines, and even worse, that the blue dots are occurring before the origin. Now, this is happening for two reasons. First of all, we have the actual position is being relative to the axis max. However, it's not accounting for the fact that we've set the origin to a static value of 5. And we've hard-coded that into the SVG itself based off of what we did in Figma. So we actually have to add +5 here to get the circle to appear at the appropriate spot. But that circle shouldn't be there at all. In fact, this should be a red timeline, because this is an order that's still in progress. It's late. So it still hasn't been delivered. So this is actually showing incorrect results, and this is a big deal. So this is one of the caveats of this, is we really need to spend more time not only developing this visual, but also testing it to make sure that it's not only appearing as we expect aesthetically, but also that it's not showing incorrect results like this. Because if we show this in our final report, it could be a huge problem. And this is something that we might not have with a simpler approach because we're simply not building a visual from scratch. So if you do choose to make a custom visual, be it in the SVG or in Neb or even in code, ensure that you take the time to test it appropriately and thoroughly so that you don't introduce these kind of mistakes. Now, how we could deal with this is in our final version. So as you can see, this issue is fixed. So not only do we have now the red line, but it also has another vector, a triangle, so an arrow, to indicate that it goes beyond the axis limits. And this basically is done by adding a new measure, work in progress, which shows the number of days in progress, so the difference between the order date and the last date with data. And if the order status is work in progress, then we use this measure, otherwise we use the actuals. So in these cases, when the order is not delivered, then we can actually determine for how long has this order been late, and this number will only keep going up with every day that it continues to be late so that these results are correct. So as you can see, again, this can become quite complex. However, we can get a fairly elegant result if we remove here the sorting, which can visually show us a lot of helpful information. But we need to balance the value that we get from this with the investment that we have to put in to make it and to test it to make sure it's accurate. There are various things that we could do in order to improve this farther if we go to the desired result here. So for instance, we could add another SVG which shows the status, but in this case, we might have a much harder time selling this specific example, trying to justify it, because we could just do the same thing with conditional formatting in the table itself. So this is something that could potentially be interesting because we have more options like creating this pill and also setting late to a darker color. We can even have it animate if we want. If I go up here, I believe that's here. So there is an animation inside of the SVG definition here. Animation here, right? Animation, otherwise like this. All right, so now it's even animating. So it's blinking to really draw attention. So we might have a case where this is really valuable, where we really want to draw the attention of people. And there's a lot of possibilities with SVGs. But again, we really need to weigh the pros and cons to make sure that this is going to be worth our time investment and that we're not going to be creating an overcomplicated report. To conclude, what we've talked about today is that there are cases when you need to show the data in a very specific way, and it's not possible with the core visuals of Power BI. In those instances, you want to try to think about what possibilities are available with custom visuals, because you could potentially create a custom visual in order to show the data the way that you need to show it. Before you do this, you need to make sure that this is really going to be useful and valuable for end users, and it's going to be worth your time investment, not only to build it, but also to test it. You also need to keep in mind that depending on the approach you choose, and that's going to depend on your situation, your skills, your scenario, depending on what approach you choose, you might be introducing additional complexity, both to maintain the report, but also to fix it if there are issues for your future self and also for future developers. This is indeed a very valuable approach, and there's a lot of possibilities. However, it's important to keep in mind that sometimes simpler is better. So it's all about choosing what works best for you. It depends at the end of the day. Enjoy making reports. Da 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 da. La da 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 da. Da 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 da. La da 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 da. La da 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 da. Da 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 da. La da 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 da. La da 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 da. Da 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 da. Da, 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 da. Da, 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 da.